Okay, honors kiddos, we are going to go through the honors review packet for the Unit 7 test, which is on right triangles. I'm not going to do every single problem, but there's a key on Blackboard that you can use. It'll have all the answers but no work shown, so make sure you check your answers before class when you come on Monday or Tuesday for those of you in other classes. Well, let's just jump right in. Number 1 says a right triangle is shown. What angle measure is closest to the value of x? So the real thing you just have to do is figure out which method to use. I'm solving for an angle, so I can't use the Pythagorean theorem. It's not a special right triangle, so this is going to be a trig problem. So I'll let you guys solve this by yourself, but I'll give you the hint that you're going to be using trig to solve this. Specifically, once you solve, since x is going to be in your angle, you're going to have to use inverse trig. Number 2 is also going to be a trig problem because you have an angle that's not 30, 60, or 45, so this will also be a trig problem. Here we're trying to figure out what the 3 side lengths, so notice it's all about side lengths, of a right triangle. Well, if we want to figure out a 3 side angle, that's when we use a squared plus b squared, and we need to make sure it equals c squared. Remember, c has to be the hypotenuse. Okay? So what you're going to do is you're going to start testing these, right? So maybe you'll try 17 squared plus 20 squared, and you want to see if that equals 21 squared. Well, I'm going to tell you now, that group doesn't work. You need to test these different groups until you get 3 that fulfill the Pythagorean theorem. So that's what you need to do for number 3. Number 4 is another trig problem. Notice we have an angle that's not 30, 60, or 45. So that's going to be another trig problem. Let's do number 5. It says an equilateral triangle is folded in half. So this has just got cut in half. What is the length of x? Well, if it got folded in half, this 60 is going to go right here. That means this is going to be 30. We know these have to add up to 180, so 90 and 60 have already been used up. We've got 30 left. I know since the whole bottom was 14, when it's folded in half, that's going to be 7. So think about your 30, 60, 90 rules and which of these will be your correct answer. Remember, the key's on Blackboard. You can check a little later. Okay. Here's again, which of the following sets of lengths, so we're not talking about angles, just lengths, can be the sides of a right triangle. So once again, you're going to test a squared plus b squared equals c squared, and only one of these 4 sets, if you plug it in, will give you the right answer. Remember, make sure that c squared is your longest side. Remember, the hypotenuse is always the longest side. Okay. Here's our next part. Express each in simplest radical form. Well, simplest radical form really means a couple or 2 big things. The first is, or no, I guess it means 3 things. 1, if you have a radical in the denominator, you need to find a way to make so the denominator doesn't have a radical in it. We call rationalizing our denominator. Our second thing is if we're multiplying things together, we need to combine them. And our third thing is if we have something under the radical that can be simplified. So for instance, the square root of 18 is the same thing as this, which is the same thing as this. If we can simplify it, we need to do that, okay? So number 7, our issue here is we have a radical in our denominator. So the easiest thing to do is say, okay, if I multiply by a value of 1, the value of this won't change. So anything divided by itself is the same as 1. If I multiply across the top, I get root 3. If I multiply across the bottom, I get root 3 times root 3, which is just 3. So notice, I still have a fraction, but there's no radical in the denominator. It's just a kind of like a math grammar rule that we follow. But that's what we call rationalizing our denominator. We multiply by something with a value of 1, which will help the denominator not have a radical anymore. Okay, we're multiplying these together. So 2 times 6 is 12. They're both under the radical, so it stays under the radical. But root 12 is the same as root 4 times root 3. Well, root 4 is a value of 2. Remember, we're looking for perfect squares, so 4 is a perfect square. Root 3. So we multiplied and then we simplified. Okay, we still have a radical in our denominator. We need to find a way to get rid of it. We use rationalizing our denominator, which says multiply by something that has a value of 1. Okay, so in the numerator I get 5 root 2. In the denominator I'm going to just get 2. We can only simplify things that are outside or inside, so 5 and 2 don't simplify, so we're going to leave it just like this. Okay, let's keep going. See if we can get through part 3 for this first video. We want to find the value of each trig, and then here's a really important word, ratio. It never said solve. We just want to know what like the trig relationship is for a given angle. So for angle D, here's my opposite side, here's my adjacent side, here's my hypotenuse. Okay, so cosine is A over H. So for those of you who had forgotten, remember we have so, ca, toa, or another way of putting it is so, ka, toa. Okay, remember cosine, C, is A over H. So A over H is 3/5. We're not solving. I just want the cosine relationship for angle D. Let's do tan of E. Okay. Here's O for E. Here's adjacent for E. Here's H for angle E. Tangent is O over A. O over A, so 3/4. Okay. Down here, all you're doing is just plugging this into your calculator. It's helping you remember that all of these just have a numerical value. So if you in your calculator type in sine of 46, you just get 0.719. Okay, let's try tangent of 91. You guys can't see that. Oh, I got -57. Well, that doesn't make sense to get a negative value when we plug something in for tangent. Let's see if we can figure out why this is being so weird. Well, first of all, can I have a right triangle that has an angle of 91 degrees? If that's my right triangle and this is 91, these two already add up to more than 180 degrees. So first of all, we can't even have a right triangle that has an angle of 91, so that's why this doesn't work. Well, really, that is the reason it doesn't work. So we're just going to leave it like that for now. Put the value so people understand. But I'll put this and say it doesn't make sense. Because of that. Okay, let's keep going. Use a calculator to find each angle measure rounded to the nearest degree. Well, right here we say that tangent of A equals 4.7. So if I typed in tangent of whatever angle A was, I would get this. Well, we want to solve for the measure of angle A. We want to get A by itself. Well, the only way to get A outside of the tangent is by doing tan inverse to both sides. Okay, so tangent and tangent inverse undo each other. So A is by itself, and all I'm going to do is type in inverse tangent of 4.7, and that gives me an answer of 77.989 degrees. Okay, so you guys can finish those by yourself. We've practiced trig a lot, so I don't want to spend too much time on this. But I will do two of them. We'll do 22 and 24. So 22, here's my angle. So remember, we've got some steps. So we circle our angle. We label our sides. Remember O, A, and H. And then we use SOHCAHTOA to solve. So circle my angle, labeling my sides, O and H. So I'm going to use SOHCAHTOA to determine I'm going to use sine equals O over H. Now when X is in the denominator, that's our hardest one. It's when we use our switcheroo. What we're really just going to do is we're going to multiply both sides by X to get X out of the denominator. But then I have to divide by sine of 61 to get X by itself. Okay, so when I type that into my calculator, I get that X has a length of 18.294 if you round correctly. For those of you who are watching, if you're in my class, Mrs. Barnes' class, remember we're going to always round to 3 decimal places. For those of you in other classes, your teacher might have given you different rounding instructions. Make sure you follow their rounding instructions. But this answer makes sense because it's the longest side, and it's longer than 16, so that's good. Okay, number 24. Here's my angle, labeling my sides. There's A and O, so I'm going to use tangent of my angle equals O over A. To undo tangent, I use tangent inverse. and I get 42.9299, so 923. Let's actually do 23 really fast just because we haven't done one quite like it yet. So here's my angle, here's my O and my H. That means I'm going to use sine of my angle equals x over 8. Now, because we've done more difficult ones, sometimes people trip up here. We need to get x by itself, which means all I have to do is get this 80 moved. And the way I undo dividing by 80 is by multiplying by 80. So now I have x by itself. It equals sine of 48. Oopsies, times 80. If you put the 80 at the end, make sure when you're in your calculator you close your parentheses for the 48. We saw in class why that's important. Okay, I get 59. Notice I close my parentheses, sine of 48, and then whatever that value is, we multiply by 80. So that's going to be 59.452 with rounding. Okay, I'm going to stop this video, and then I'll start a new one for part 4 in a second.